Good morning, everyone. Welcome to Unit 1, Day 14. Today we're going to be talking about the function again and its definition. We're going to kind of intermix the graph and the table today. So we talked about the table on the first day this week. We talked about the graph on Tuesday, and today we're just going to kind of do both and go over both of them again to make sure that you have that definition of a function nailed down. All right. For today's review, we're just going to go over how to generate a table and a graph from the rule of a function. So that's where we will begin. So our goal with a problem like this is to take this rule that they give us, right, the function rule that they give us, and use it to generate a table here. And then once I have the table, I can take the points that I generate from the table and plot them on the graph. Okay. So for my table here, what I'm going to do is I'm going to put in x equals 0, 1, 2, 3, and 4. Okay, just to get some x values going. You might not even choose the same x values that I do. Maybe you choose some different ones, and that's okay. But I'm just going in order here to keep it simple. All right. Now to figure out f of x, or our y value, I need to take my x values and plug them into the rule. So for instance, on this first one, if I plug a 0 in for x, I'm going to get negative 2 times 0 minus 3. And negative 2 times 0 is 0, and 0 minus 3 equals negative 3. So it tells me when I put a 0 in, I get a negative 3 out. So there's my first point, 0, negative 3. And then I would repeat the process again by plugging in a 1. So I'm going to do the same thing over again. So I've got negative 2 times 1 this time. So remember, we did 0 last time, but now we're inputting a 1. Right? So negative 2 times 1 is negative 2. And negative 2 minus 3 is negative 5. So when I put a 1 in, I got a negative 5 out. And we can see that happening over here. Now I'm going to do it again, this time with a 2, so we've got negative 2 times 2 minus 3, and negative 2 times 2 is negative 4, and negative 4 minus 3 is negative 7. So maybe at this point you're starting to recognize a pattern over here in the table, and I hope that if you do recognize a pattern that you use the pattern to your advantage. You might notice that we're going 3, 5, 7, so it looks like we're going with the odd numbers here, and we're going down by 2, so this next one should be a negative 9 and then a negative 11 using the pattern that I saw from the first 3. All right. Now that I have generated my table using the function rule, I'm going to plot points from my table on the graph. Okay, so I'm going to come over here and make sure I can see my entire graph. And the first point that we have here is 0, negative 3. So I'm going to go to my origin. I go 0, left or right. So I'm not going to go left or right at all because I have a 0. And then I go down to 3, since the 3 was negative. The next point is at 1, negative 5. So I'm going to go to the right 1 and down 5. The next point is at 2, negative 7. So I'm going to start at my origin. I go right 2 and down 7. My next point is at 3, negative 9. So that means I'll go right 3, down negative 9. Right? Input 3, output negative 9. And if I try and do 4, negative 11, it will take me off the graph, so I'm not going to worry about plotting that point. And then once I have all of my points that I can plot on the graph, I'm going to draw a line through those points because I can see that it's trying to make a line. Let's see if I can get this line to go through. There we go. And there's my graph, there's my table, and there's my equation. All right, so let's get back to the definition of a function. Now remember last time we had talked about this. I'll repeat this definition again. We had talked about the definition of a function means that every single input, right? So when we talk about our x values and the inputs on a given table, every single one of these inputs should only have exactly one output. Okay, so for instance, 1 in this case goes to 2. So when I put a 1 in, I get a 2 out. That 2 should be the only thing that 1 can get to. All right, there shouldn't be another number that 1 can output. All right, so we look through this, and what I like to look for in the table, I like to look for inputs that are I like to look for the inputs that have more than one of themselves. So when I look at 1 here and I go through the rest of these numbers, there's no other 1s. So that means that 1 would only go to 2 based on what I can see in this table. All right. Now this input 4 also goes to 2, but that's okay, right? Because 4 only goes to 2 and 1 only goes to 2. The input could only have one output. All right. Now I notice here I have a 5, and then I notice over here I have a 5 again. All right. So 5 over here goes to 7, and 5 over here goes to 0. So the input of 5, okay, so we can say when x equals 5, y equals 7 or 0. And this is not allowed, right? I can get 7 here or I can get 0 here. That's not allowed. We can't have more than one output for any input. So this is not a function. And if you can find even just one input that does this, that's enough to say that it's not a function. All right. So now what they want to do is they want us to fix the table. All right. So we have all of our inputs here, 1, 4, 5, 8, 9, 3, 4, 5, just like we had up here in our first table. And I'm going to keep everything the same except for the 5s, because that's where we had the issue. And you might notice some other issues in there as well. All right. So 4 is another one that seems to repeat itself. And in one instance, when x equals 4, y is 5, right? That's over here. But over here, it equals 2. So that's another input that has multiple outputs, and that's not okay. All right. So the issues are at 4 and 5. Everything else seems to be okay. So I'm just going to bring those outputs down. So 8 can go to 9, 9 can go to 6, 3 can go to 4, but 4 and 5 are the ones that had an issue. So remember, in this one, 4 went to 5, so I'm going to put my 5 down here, and then I'm going to go find the other 4 and make sure it only goes to 5. So 4 to 5, 4 to 5. And then I'm going to do the same thing with the 5, right? So in this first instance, 5 went to 7. So I'm going to go over here and say, well, 5 can only go to 7 now. So I got rid of the 0 and I got rid of the 2 and replaced it with the 5 and the 7 from the first instance in their table. Okay, so now this represents a function. Every single input only has one output. Okay, so let's talk about graphs. All right, how do we tell if a graph is a function or not? And yesterday I had demonstrated this concept of drawing a vertical line into your graph to determine whether or not an input has more than one output. All right, so this graph that we're looking at here is not a function, and I'm going to show you why. Okay, I'm going to choose an input of x equals -3. So I'm going to go to my graph and I'm going to go to -3 here. And when I get to -3, to find an output, I would go to wherever my function is at -3. So I would either go directly up or I'd go directly down to get to my function. So if I go directly up, I get to my function at this point, right? So this would have an input of 3 and an output of 1, right? So when x equals -3, y equals 1. But if I go down, I hit my function again at this point. And if I trace that back to the y-axis, y could be -2. So that is a demonstration of an input, -3, that has more than one output. I could get 1 or -2 if I were to select that -3. So it's almost like I'm drawing a vertical line through my graph. And if it's going to be a function, when I draw that vertical line, I can only hit my function, the blue thing, once. Okay? So you can quickly tell if something is a function by taking a vertical line, which I have ready for us over here, right, and just running it across your graph. And if at any point that vertical line hits more than once, which it does right here, we can see 1, 2, 3 hits on the blue line by our vertical line, that tells you right away that thing is not a function. Okay, oops, another place could be over here, right? So you might notice it hits here once and it hits up here again. So that would be a place where it hits twice. So there's a lot of different ways, there's a lot of different places where we can show this thing is not a function. Okay, so when I draw that vertical line, it should only hit the blue function once, no matter where I put that vertical line. Now over here, it only hits once, right? But it's got to be everywhere on the graph. There cannot be any place on the graph that blue line hits that the vertical line hits the blue function more than once, and it does several times over here. Okay, so let's take a look at our next graph, and this one is a function. Okay, I'll just start off by telling you that this is a function, and I'll demonstrate that again with my vertical line. I'm going to take my vertical line and just run it across the graph, and you'll notice that no matter where I put this thing, it only hits that blue wave one time. There is never a place where I can put that vertical line where it hits more than once. So as I scan that graph, right, it's almost like running the barcode scanner at the grocery store over your graph. There's never a place where I'm going to hit more than once. Okay, and this vertical line thing that I'm doing, we call this a vertical line test, and you can do this. I know I'm doing it with technology and on the computer right now, but if you have this printed out on a piece of paper, you can do this with a ruler. You can draw your own straight line. You can just draw several of them right on your graph and see if you can get a vertical line to hit anywhere more than once. Okay, so with this case, I would confidently say this is a function. If you think it's not a function, you should find the input like I did up here and tell me what the outputs are, just to show that there's more than one. Alright guys, that's it for today. Have a great day. If you have any questions on this stuff, make sure you let me know in the Zoom chat. Have a great day.